Alright guys, starting up a new chapter here, or a new unit, if you will. We're going to talk about the graphs of trigonometric functions. For the next 3 lessons, we're going to be talking about how to graph the 6 trig functions that we've learned about: sine, cosine, tangent, cotangent, cosecant, secant. And we're kind of going to go by twos. They seem to go in pairs of twos. Sine and cosine are the ones we're going to focus on today. They have a lot in common. Their graphs and how you do those graphs are quite similar. So we're going to focus on those. So let's go ahead and jump in and see what graphs of sine and cosine look like. I'm going to do this problem here real quick. And just so you guys know, I posted some student notes for you guys today, just to kind of keep up with what I've always been doing with you guys. Is sometimes I'll print some notes for you. And I went ahead and did that for this lesson, for those of you guys that have heeded my advice and decided to keep taking notes. I find that for those people that move on into calculus, they really like their trig notes, their trig reference in particular. So anyway, here we go. So what I'm going to do is I'm going to create a function. Okay, remember, a function is where you have an input and an output. So this function, the input is going to be the angle theta, and the output will be what I get if I plug that angle into cosine. So what I'm going to call this then is I'm going to call this a cosine function. So the input is the angle, the output is what I get after I plug that angle into cosine. So hopefully you guys would be able to tell me what these things are. So if I were to plug in 0, so if I want to find f of 0, that means I'm going to plug 0 into cosine. Now, if I did that, you'd think of your unit circle. You'd find where the radian 0 is on your unit circle and find the cosine value, which is the x value. What is the x value at the radian 0? The answer is 1. And we're going to keep doing that process. Next, I want to plug in pi over 2. So if I plugged in pi over 2, what's the x value at pi over 2? The answer is 0. And you just keep doing that with the rest. If you plugged in pi, you'd get -1. If you plugged in 3 pi over 2, you'd get 0. And if you plugged in 2 pi, you're back to 1 again. Now there's a whole bunch of other x values that I didn't plug in, but that's because these 5 numbers here are kind of enough to give us the picture that we need. What I'm going to do is I'm going to graph these. Now on this graph over here, the input variable is theta. So I'm going to put theta as my x-axis, and the output, the cosine value that I get, which are these numbers over here actually, those are going to be my y values. So, all right. Now it's kind of confusing because, like I said, on your unit circle, these are x values. But on this graph over here, we're plotting them as y's, and we're letting the theta represent the x-axis. All right, so my first ordered pair is the point 0, 1. So that would be right here. My next ordered pair would be pi over 2 and 0. My next ordered pair would be pi, -1. My next ordered pair would be 3 pi over 2 and 0. And my last one would be 1. Now, you guys might try to connect these dots with a V, but I'm going to say don't do that. They actually don't connect with straight lines. They connect with a curving line like this. And there it is. Now, as you guys know, cosine is, there's no end to what you can plug into cosine. I just picked these ones. I went from 0 all the way up to 2 pi, but you guys know what happens after that. You just start going back around the circle and you get all the same answers all over again. And so since you start getting the same answers again, this shape right here just repeats. It just keeps going. Cosine is a wave that never stops just wiggling up and down like that. But I'll go ahead and highlight this part because this part is what I'll call the the basic shape of cosine, because it starts up here at 1, goes down to -1 by the time you get to pi, and then swings back up to 1 by the time you get to pi. And after that, it just starts over, and so you get this continuous wave. Okay? Now, for your guys' first student practice, I'm going to be having you guys do the same thing, but with sine. So you guys are going to complete this table for sine. So you're going to plug in 0 for sine, and you're going to see what you get. Plug in a pi over 2 to sine, and pi, and so on. And remember, when you are plugging it into sine is the y value in the unit circle. When you're all done, I'd like you guys to graph your circle and see what you get. So go ahead and pause the video here and complete that. And then when you unpause it, I will have the answer up for you. So this is what you guys should have had. These are the correct answers in the table here, 0, 1, 0, -1, 0. And the graph over here would look like this. Now, just like cosine, sine just keeps going. And once again, as you go just after you complete one cycle here, right, from 0 to 2 pi, after that, it's just going to repeat. So we're going to get another wave over here. It goes backwards as well, and so on. So the wave just keeps going. So in case you guys didn't notice, this graph looks a lot like the last graph that I did, the cosine graph. They're very similar. But there is a slight difference. I'm going to draw the cosine graph that I had on the last page. And let me do blue. Now, as you guys can see, the sine and the cosine graph are basically the same thing. It's just that they're starting in different places. Cosine starts up here at 1, whereas sine starts down here. Colors on my pen real quick. Sine starts down here at 0. But other than that, they have the same exact pattern. For every 90 degrees, or pi over 2 radians, they go down 1, and then down 1 again. And then after that, they go back up 1, up 1. Same thing here, up 1, and then down 1, up 1, up. They just kind of keep having that same pattern of rises and falls. So sine and cosine look very similar. They just bounce back and forth between 1, 0, and -1 repeatedly. And they do that on intervals of pi over 2, going up by 90 degrees each time. The only difference between the two waves is that cosine starts at 1 on the y-axis, whereas sine starts at 0 on the y-axis. Okay, so those are sine and cosine graphs. So let's talk a little bit more about that. We have some notes specifically detailing these things we've observed. So sine starts at 0. Now I'm going to say, a better way of saying that is the midline. Sine starts at the midline. The midline is, as you guys know, it goes from 1 to -1, right? And sine starts at the midline. It starts in the middle. Now, the reason why I say that it's better to use the word midline than 0 is because later on in today's lesson, you're going to find that it's not 0 it always starts at, but it always does start at the midline, okay? Whereas cosine always starts at 1, but a better way of saying that would be the max. Once again, it starts at 1. That's the highest value, the maximum value. So cosine starts high, whereas sine starts at the midline. But other than that, they have the same basic pattern. So sine starts at the midline and goes up. Cosine starts at the max and goes down after that. They follow the same pattern of rises and falls. In other words, it's up, they always go up 2 spaces and then down 2 spaces, up 2 spaces, down 2 spaces, up 2 spaces, down 2 spaces, crossing 0 along the way. They have the same domain. Domain is all the possible values for the input. In other words, theta. You can plug in anything you want to for theta. So theta can be anything from positive infinity to negative infinity. There's no limit on what you're allowed to plug in to a sine function or a cosine function. You'll always get an answer. But the range, the possible values of y, you can see that by just looking at the graph. The highest y value is 1 and the lowest one is -1. So it's between 1 and -1. However, their highest and lowest values will change a little bit later in today's lesson, but they will always have some kind of range restriction, but the domain is always infinite. Okay, so part of our can't be seen. I'm going to lower the screen a little bit here. All right, so let's talk about this here, parts of sine and cosine graphs. So the highest point, the peak of the waves, are what we're going to call the max, and the lowest point of the waves is what we're going to call the minimum, and the line in the middle is what we're going to call the midline. Now the distance from the midline to either the max or the min, they're the same distance, but that distance is what we're going to call the amplitude of the sine wave. Now a period is one cycle. What do I mean by that? So as you guys know, on the unit circle, you start at 0, you go around, and by the time you get there, you completed a cycle. And if you go around, you start getting a repeat of all the same answers again. Go around again, you get a repeat of all the same answers again and again and again, never stops. So a period represents one full cycle around the unit circle. So here we plugged in like maybe 0, and here we plugged in 2 pi, and that was pi over 2, this was pi, 3 pi over 2, and 2 pi. And that was our full cycle. That's a period. But after that, it just repeats. You get the same shape again, just a little bit further along the curve, because all the angles around here are coterminal with these angles, and therefore they give you the same output, the same wave. Okay? So that's what we mean by one period. It just means one cycle through all the angles on the unit circle. Now, the domain, as we said, is all real numbers. It goes on forever to the left and right. It never stops because there's no limitation on what you're allowed to plug in for the angle. But the range is always going to be stuck between the minimum and the maximum. How do you find the minimum and the maximum? Well, you're going to start it. You're going to know what your midline is first. And you're also going to know what your amplitude is. Today's lesson, when you look at the graphs or the equations that we're going to be graphing, in the equation, you can tell right away what the midline is. You can also tell what the amplitude is. If you just take the amplitude and subtract that from the midline, that will tell you where the minimum point is. Add the amplitude to the midline, you'll get the max. So if you start here and add the amplitude, you get the max. If you start here and subtract the amplitude, you get the min. So, and that will tell you the range of your function, because it always has to be between the minimum and the maximum y values possible. So let's review transformations a little bit. As you guys may know, when you have a function and you multiply it by a number, that's a vertical stretch. Or it could be a shrink. It depends. I misspelled. Oh well. It's a stretch if a is greater than 1, and it's a shrink if the absolute value of a, if the absolute value of a is less than 1. So in other words, we don't pay attention to whether a is negative or positive. We just look at the number itself, and if that number is bigger than 1, then it's a stretch. If it's less than 1, then it's a shrink. Another transformation we talked about was adding a number out here. And what that is that's a vertical translation. Less fancy word for that is a shift. So if it's a positive k, we're adding k, then it's a shift upwards. If it's a negative k, then it's a shift downwards. So those were a couple of things that we looked at. Another thing to pay attention to is whether a is positive or negative. If you have a positive a, it's normal. We'll just say it goes the normal direction. But if it's a negative a, it's upside down. It's a reflection. So that's just a quick review of some transformations that we talked about. all of these are vertical transformations. Horizontal transformations are things that happen on the inside of the parentheses, but we're going to save that for a later discussion. They're a little bit tricky when it comes to dealing with trigonometric functions. Vertical transformations are actually pretty straightforward and easy to deal with. So let me show you how to deal with the vertical transformations when we're talking about sine and cosine graphs. All right, so here we have a sine function, and here we have a cosine function, right? Now, the a, if you were to multiply your sine or your cosine by an a, what that's going to do is that's going to stretch it or shrink it. But now, before I write stretch or shrink, I'm actually not going to write that at all. Let's take this wave, right? If I were to stretch this graph, what would that change? It would change two things. It wouldn't change the period. It still starts at here and still ends here. So it still has the same width. But the maximum height will be different. Oops. The maximum height will be different. The minimum height will be different. And the amplitude will be different. And so what the A does for sine and cosine graphs is basically it tells you what the amplitude is. Usually the amplitude is 1. But if you multiply your functions by A, that's what your amplitude is going to become now. So this is going to be the amplitude or the stretch of our function. Okay? Plus K. Let's talk about what plus K does for our graphs here. I'll put equals Y. All right. What is the plus K? As you guys know, if this is what our graph usually looks like, right? What would a plus K do? Well, we reviewed that in the last slide a little bit. It would shift your graph up. It's not going to make it longer. It's not going to make it shorter. It's going to have the same period. All it does is it shifts everything up. So that will also affect your maximum, your minimum, and your midline. Now, usually on these graphs, the midline is on the x-axis, 0. But when you shift it up, however far you shift it up, that will be your new midline. And so K basically represents your midline. So we know our midline, we know our amplitude, we know what sine looks like, we know what cosine looks like. We're ready to graph. So let's go ahead and see if we could bring this into practice. Here are the steps for graphing sine and cosine for now. We're going to add some stuff to these steps a little bit later on, but for now, we're going to be just starting easy. So the first thing you're going to do is you're going to graph your midline. Okay, so remember, I'm going to use sine as an example here. Your midline is K. All right, then we're going to use the amplitude, which is A, to find the min and the max. The minimum is your amplitude. I guess I'll just put A, plus your midline. Actually, that's your max. Let me back up a little bit. Your minimum is the midline, actually, first, minus the amplitude, and your maximum is your midline plus the amplitude. And then we're ready to start, and then we're ready to draw our curve. And just remember that sine starts at the midline and goes up, and cosine starts at the maximum, and after that, there's only one way to go, it's down. So, all right, so here is example 1. Identify the midline, the amplitude, and graph the function. After that, we need to identify the range and the domain. So we have a lot of parts we need to do here. A, B, C, D, E. So let's do that. A, what is my midline for number 1? My midline is the number that's being subtracted or added to the function. So in this case, it's 2. Negative 2, sorry. B, what's the amplitude? The amplitude is the number that's multiplying your function. We're going to say 3. Now, it's actually better to say the amplitude is the absolute value of this number because we don't really care about the sign. You'll notice none of them are negative right now. We're going to talk about that later, but the amplitude it's just a distance, the length, so it's not something that we really include a negative with. The negative means something else, but we'll get to that a little bit later. So for now, we're going to say our amplitude is 3. Now, I'm going to graph the function now. And I'll do that over here on the side. So first of all, I'm going to plot my midline at -2. There's my midline. And then I'm going to plot my amplitude. I'm sorry, my maximum and my minimum lines. Now, since the amplitude of this graph is 3, starting at the midline, I'm going to go up 3 spaces. So 1, 2, 3. That's going to be my maximum. Add 3. If you add your amplitude to your midline, you get your max. And to find your minimum, you're going to go down 3 from your midline. So starting at my midline, I'm going to go down 3. 1, 2, 3. And that's my min. Now the next thing we have to do to graph it is we have to look at what kind of function we're graphing. It's cosine. So what did we say about cosine? Where does cosine start? Does it start at the max and go down, or does it start at the midline and go up? Look at your notes there, and you'll see that cosine starts at the maximum. And by start, I mean at 0 for now. It starts at 0 and then it goes down. But we have the same, we're going to be using the same angles that we used before, just so you guys know for now. Pi over 2, pi, 3 pi over 2. We're just going to be going in those 90-degree intervals like we were before. So we start here and then we go down 1. I'm sorry, I was supposed to go to the midline on that. I do that quite frequently. So you go from the max down to the midline, and then you go down again till you get to the minimum. Then you come back up to the midline by the time you get to 3 pi over 2. And by the time you get to 2 pi, you're back up to the top. So you should have that shape. So you have these 5 points that you're graphing. Down 1, down 1, up 1, up 1. So every time you go over, it's down, over, down, over, up, over, up. Okay? And there's your graph. And as I mentioned before, these graphs do just kind of keep going, so you can kind of just fudge the rest of it. That's that. Okay. Now part D asks us for the range. The range are all the possible values of y. It can be anywhere from this line to this line. Now, how high up is that line? That's at 1, so that's the max. And my lowest point here is -5. So the lowest line here is down here at -5. So the y values of this function can be anywhere between 1 and -5. E, what is the domain? The domain, as we mentioned, for sine and cosine is all real numbers. There is no limit on what x and y can be. It exists everywhere going to the right and everywhere going to the left. So there's no limit on the domain. And there's number 1. Let's go ahead and do number 2. All right, number 2. The midline. It's the amplitude. 3 again. Ready to graph? So get out your notes, see if you can follow along with us. So we're going to make our graph. We're going to use the same angles we did last time. Pi over 2, pi, 3 pi over 2, and 2 pi. We start, according to the notes I gave you, we start by graphing our midline. So it's a positive 2 this time, so I'm going to go up 2. Then I'm going to use my amplitude to find the max. So starting from my midline 2, I'm going to go up 3. My amplitude is 3. Put a new dotted line representing my maximum line. And then starting from my midline, I'm going to go down 3. 1, 2. Put a new dotted line representing my minimum. All right. Now, since this is a sine function, where do we start? Well, we always start on the y-axis, so let's be clear about that. For now, that will change later on, but for now, and for quite a few lessons now, actually, we'll always be starting on the y-axis. But where do we start? Do I start at the max, the mid, or the minimum? Since it's sine, we're going to start at the midline. Now, since you're starting at the midline, this is a little bit confusing. I'm going to go over, and do I go down or do I go over and up? Which way do we go? Well, look at your notes. It should tell you we go up. So from here to here, we're going up. Now after that, we can't go above the maximum, so now we got to start coming back down again. So we went over 1, up 1. Now we're going to go over 1, down 1. Over 1, down 1 again, down all the way to the minimum. And then over 1 back up to the midline. So notice the graph just constantly bounces between the midline, the max, midline, min. And there's our sine wave, and then you're going to just go ahead and add the rest of it for looks. All right, let's go ahead and put D. D is our range. What's the range on this one? Well, that's max and min again. My maximum line is at 5, and my minimum line is at -1. So y can be anything between -1 and 5. The domain, as we've already mentioned, for both sine and cosine is always all real numbers. X, or I mean, in this case, theta, can be anything. The next one I'm going to encourage you guys to treat kind of like a guided practice, so I'm just going to lead you guys with questions here. I don't like this problem, though, because it's too repetitive. Make up a different one here. Okay, so the first thing I want you guys to do is be ready to beat me to the punchline here. What do I got to find first? Hopefully you guys are recognizing we need to find the midline first. So what is the midline now? Hopefully you guys know that that is -3. Part B, what's the next thing I need to do? We're looking next to find the amplitude. What is the amplitude? It's 4. Part C, we're ready to graph it. So I'll do that over here. What are the angles that I'm going to put on the x-axis? They're the same ones we've been using. The first one is pi over 2. The next one is pi. The next one is 3 pi over 2. Last one is 2 pi. Next, this is where, well, no, never mind, it's not the hard part. What do we do next? We're going to graph something. What do we graph next? Hopefully you guys know we start by graphing the midline now. The midline is -3, so you would have done something like this then, hopefully. Okay, now what do we do? Next thing we should have done is you should have found your maximum and your minimum by adding the amplitude to the midline or subtracting it. So adding means go up, so I'm going to go up 4 spaces, 1, 2, 3, 4, and that's going to be my maximum point now. And I'm going to go down 4 spaces from the midline, and that would be my minimum. Now here's the hardest part. Where do you put your very first starting point? I would encourage you to pause the video here and really give this one a shot, see if you can figure it out. Well, as you guys know, we start on the y-axis for sure. But we have three possible places, either the maximum, the midline, or the minimum. Where do we put our dot? Well, since it's cosine, we start at the max. So you should have had your starting dot here. And the next thing we have to do is we have to draw our wave. So we're always going to, every move, we're always going to go over one space. But you know, where you put your dot is also a little tricky. So see if you guys can figure out where the next few dots go. Go ahead. Pause the video here and see if you can draw the wave. So here's what you guys should have done. You should have went over one and down to the midline, over one and down to the minimum, over one space and back up to the midline, over one and back up to the max. And don't forget, when you connect these dots, do it with a smooth curve, not with a straight line. And then after that, go ahead and just finish the wave manually. All right, part B. What are you guys identifying as the range here? Go ahead and see if you can figure out your range. Okay, hopefully you guys got 1 and -7. Highest point is 1, lowest point is -7 on the y-axis. All right, part E, pretty sure you guys know this one. It's all real numbers. So that's graphing basic sine and cosine functions. So that was like a guided practice. So I have a couple here for you guys. Now, just as a special heads up here as you're doing this, I'm going to make a little bit of a change to these before you begin. I'm going to get rid of this one really quick. Okay. So my special little note that I want to make for you guys is this, is that what happens if you're missing A? In other words, what if that number in the front isn't there? What would it be? It would mean that A equals 1, just so you know. And what happens if you're missing K? That would mean that K equals 0. Numbers that are missing by addition are 0. Numbers that are missing by multiplication are 1. So another little note you might want to add in notes. But go ahead and do this. Now, whenever I go over the answers here, I'm not going to do the A, B, C, D, E, F thing that I was doing before. I'm just going to draw the graphs. I'm going to assume that if you have the graphs, you probably know the answers to the other ones. Okay, so go ahead and pause the video here. Take a couple minutes to do as many of those as you can. So here's your answers to 1, 2, and 3. Notice that for numbers 1 and 2, they're both cosine waves, so they both start at their maxes. And the third one down here is a sine wave starting at its midline. The midline for number 3 is at 1. The maximum at 2 is at -1, and the maximum at number 1 is +5, it looks like. So, now a couple things I didn't do to save space on my small screen that I have here is I didn't put the angles on the axis. They're the same 4 angles that we've been using. And also, just to kind of make the picture a little more clear, I didn't finish the waves, but technically you should keep the waves going after that in somewhat of a symmetrical fashion. And there you go. All right. All right. So let's talk about vertical reflections real quick. We're going to move on to our second part of our lesson here. As you guys know, cosine starts high and then goes down, right? But what happens if we take our cosine function and we multiply it by a negative? Well, that's going to flip it upside down. So instead of looking like this picture here on the left, it's going to go like that, right? So if you put a negative in front of cosine, then it won't start at the max anymore. Now it will start at the minimum. And what about sine? Well, sine, as you guys remember, sine starts at the midline and goes up, right? So it goes like this. But what if you were to reflect it? Well, if you reflected this upside down, it's still going to start at the midline, but now it's going to go down. So it would look a little bit different if you put a negative in front. So here's the differences. Usually with cosine, you start at the max, but if there's a negative in front, you start at the minimum line. With sine, usually you start at the midline and go up, but if it's negative, you start at the midline and go down. Okay. Other than that, there's really not much different that's going to happen due to the reflection. So let's do number 1 here. So for number 1, pi over 2, pi, 3 pi over 2, 2 pi. Let's start by graphing our midline. All we're going to do is graph this time. We're not going to identify all the parts. We're just going to jump right into it. So let's graph the midline. The midline is 3. Now I don't have a number here in the front of my sine, so I'm going to assume that's a 1, which means that my amplitude is a 1. So I'm going to go up 1 space from there. Then I'm going to go down 1 space from my midline to find my minimum. So all that's old news, none of that's new. But here's where the difference is. We see that there's a negative in the front, and it's a sine function. Now usually sine starts at the midline and goes up. But since this is a negative sign, it's been reflected. So it's going to start at the midline and go down. After that, you just follow through with the regular wave pattern. So down and then back up, back up. So there's our wave. Okay. Number 2. For this one, let's go ahead and put our angles on. Pi over 2. And by the way, instead of radians, you can put degrees, but I'm just trying to get you guys used to radians because they're kind of uncommon for us right now because we're just learning them. But you could do degrees instead. You can go from 0 to 90 to 180 to 270. You're just going up by intervals of 90 degrees instead of by intervals of pi over 2. But anyway, I digress. Let's continue here. So my midline, there isn't one there. And what do we say about that? When there's no midline, that means your midline is 0. So that means my midline is actually just going to be the x-axis itself. My amplitude here, however, is 2. So I'm going to go up 2 and down 2 from my midline. Find my max and my minimum. Now this is a cosine function. Usually cosine starts at the max, but in this case, since it's been reflected, it's going to start at the minimum. So up, down. There's my basic wave there. Okay, that's that. One more little practice for you guys. I would encourage you to pause the video here and try these 2 problems and see what you guys get. All right, guys, so here you go. These are your answers you should have gotten. On the first one there on the left, that's the number 1. Of course, the midline's at 1, and the amplitude's a half. So before I got to 2, I just put a dotted line in the middle there. Same thing going downwards. And since this is a reflected cosine, it starts at the minimum line and goes up from there. Number 2, this is a sine graph. The midline is 0. The maxes and mins are 2 and negative 2. And since it's a reflected sine wave, it starts at the midline and goes down. Okay. And of course, even though I didn't do it here just for teaching purposes, but you guys would want to continue these wave patterns just because they do actually just keep going after that. They don't actually stop those endpoints. Okay, there you guys have it. So that's our lesson for today. Next time we'll talk about secant and cosecant graphs.